All right, hopefully you guys are starting with this video. If you start with the other one, this is going a little bit backwards, but I wanted to talk about what you all looked at yesterday and at least walk through these problems on the back page. So hopefully you saw and kind of went to the website and read about addition and subtraction of matrices. And it's really quite easy, right? Because we're just adding the terms in each spot. So each element in the same spot is getting added together, or each element in the same spot is getting subtracted together. And hopefully you took a moment to do an addition problem one way and then do it, backwards essentially, to show that with addition, it doesn't matter what order you add the matrices in, just like addition in normal numbers, like 3 plus 2 is the same thing as 2 plus 3. But it does matter what order you subtract the matrices in. So taking one matrix minus the other matrix, if we flip that order around, it will come out a different matrix if you do the subtraction problem the other way. Just the same way that, 4 minus 2 is not the same thing as 2 minus 4, right? You get the same number, one negative, one positive, though. Same thing with those matrices. So hopefully you looked at that above. But then solving for these variables, a little bit tougher, and hopefully you were able to take the example from this site and also piece these ones together. But I want to go over them real quick, and then once we finish this, we'll hop into 12.2 and see what that's all about. So, okay, here we go. First example, we should have seen that, okay, these two matrices are set equal to each other. Equal means that they are literally the same thing. So whatever is in this spot should be the same in this spot. And since there's an 8 in that spot and 2x in the other spot, and they should be equal to each other, we can just set 2x equal to 8 and solve. Just divide both sides by 2, and we get 4. And there we go. X equals 4. And it looks like my x got bumped here, so let's add that in there. And then, of course, with the same thing with y, these two things are in the same spot. They're equivalent to each other, so 3y plus 1 equals 10. And we should subtract the 1 over to get 9, and then divide by 3 to get y equals 3. And there we go. And sorry, I'm not on Notability. This is a different recording software, so it's a little bit harder to write on here. So some of these things will be, for example, let me fix this plus sign. There we go. A little bit different, but there we go, right? So whenever we have two matrices set equal to each other, we can just set their elements equal to each other and solve. All right, let's take a look at this one. So this one was a little bit different. This one is solving for an entire matrix, matrix Z. And we're going to treat this a lot like an algebra problem. In other words, imagine we had the problem Z plus 3 equals 4, and I asked you to solve for Z. Most of you would say, or all of you would say, subtract 3 to the other side. All right, we'll figure out what Z is. Well, this is the same thing, right? We treat matrices just like we do numbers. Let's just subtract this matrix, 5, 2, 4, and 1, this little 2 by 2, and we'll subtract it to the other side like this. These will cancel over here, just like a number would. And one's positive, one's negative, and we'll be left with Z equals, and then we're just going to subtract these two matrices. So remember, each element gets subtracted by the element in the same spot. So let's start in that with the 9 up here. 9 minus 5, that is 4. And then I go over here to 0, 0 minus 2 is negative 2. Careful with that subtraction, 0 minus 2. 6 minus 4 is 2. And then, what is it? 4 minus 1 is 3. And there we go. There's our matrix Z. A lot of guys will also just kind of piece that one together without actually solving it like an algebra problem. They'll just start at the beginning and be like, okay, what needs to be added to 5 to get 9? What needs to be added to 2 to get 0? What needs to be added to 4 to get 6, and what needs to be added to 1 to get 4. And, you can see that those numbers are the numbers you're looking for. But I like the algebra way. It's always going to work that way, and it's not so much guessing and checking. All right, hopefully on this one, not too bad. It was just a bigger matrix, but you can see 9 equals 9 and 10 equals 10, so everything in the same spot is equivalent. There's an equal sign between these two matrices. So at this point, we're just going to take 3x plus 1 and set it equal to 16, right? Those two elements should equal one another. We'll subtract 1 to the other side to get 15, and then we will divide by 3 to get 5. Okay, there you go. And then let's take 2y minus 1 and set it equal to negative 5, right? So 2y y minus 1 equals negative 5. We will add 1 to the other side to get negative 4, and then we'll divide by 2 to get negative 2. And there we go. All right. So just setting up algebra problems, which then led us to this last one over here, which I found this one recently, and I thought this was super interesting considering what we've been doing recently. It's a very similar problem, right? We've got two matrices equal to each other, and so we know this element equals this element. In fact, let's go ahead and set that up. 2x, let me zoom in here, let me fix that x. 2x plus, minus y equals negative 4. And then we've got the 3x plus y equals negative 1. And if you set these two up correctly, you should have noticed that, well, this turned into a system, right? A system of equations. We're trying to solve for two variables at once in each spot. So we need to either use substitution, elimination, graphing, or if you wanted to, you could use the new ref that we talked about on Friday. So that row reduced echelon form in the calculator. But this one seems like a pretty easy elimination problem. I'm looking at those y's right now. One y is negative, one y is positive. So I think I could just add these together and save myself some time from using ref. So we get, 2 plus 3 is 5x. And then over here, negative 4 and negative 1 make negative 5. And then I'll divide by 5 to get negative 1. And so we found that x value pretty quickly. Let's plug that negative 1 back into, well, either the top or the bottom. I'm just deciding for myself which I think is easier. I guess we'll plug it into the bottom. The y is positive in that equation, which probably will make it easier than the top one. So let's go ahead and plug negative 1 in. We get negative 3 plus y. And then we will add the 3 to the other side to get a 2. And there we go, right? So adding those together. Also notice I'm starting to skip some work. I know a lot of you wanted to do that back in chapter 1, but I was, kept asking that you show your work, show your work, show your work. And I think now that we're a little bit further into the year and I've gotten to see where you guys are, if you have the confidence and the ability to do it, go for it. Don't skip everything, but certainly some of those in-between steps of showing every little thing. Now that we're in Algebra 2, you can start doing that. All right, and then this word problem, which probably, if you were to solve this, you would just subtract the two numbers, because what they have is they have the records for the first half of the season, and then they have the records for the whole season, and they want to know what happened in the second half of the season. And usually, we would just say, okay, well, let's just take the numbers from the whole season then and subtract it, whatever happened in the first half of the season, and we'll get the second half of the season. And yeah, that's true. That's actually exactly what we're going to do. But, with all this information, it's what the purpose of matrices are, is just to help organize it a little bit better so we don't miss one subtraction problem or make a mistake on one. So here's what we're going to do. We just take the records for the whole season, which 53 wins, 29 losses for Team 1, 67 wins and 15 losses for Team 2, 58 and 24, 61 and 21. And we could set this equal to like x plus the first half, but I'm going to go ahead and just do the subtraction problem. 30 and 11 losses, 29 wins and 12, 25 and 16, 24 and 17. And I'll just call this, hey, let's say it equals x, and x will be whatever the second half of the season was. So we'll go ahead and subtract, 53, I need a little bit of room down here. 53 minus 30 is 23, 29 minus 11 is 18. So it looks like Team 1 had 23 wins and 18 losses in the second half of the season. Let's see what Team 2 did. Looks like we're going to have 38 wins, and then 15 minus 12 is 3. Yeah, so Team 1 did really well. They ended up having that. So, all right, let's do 58 minus 25, which will get 33, and then 24 minus 16 is 8. So there's Team 3, second half of the year. And then, of course, 61 minus 24, which will be 37. And then 21 minus 17 will be 4. Sorry, I had to kind of run out of room there, but there we go. All right, there's our second half of the season for these teams. Hopefully I didn't make a little subtraction error there. If I did, you can fix it for me, but everything seems okay. And yeah, so there we go. There's everything we need to know about adding and subtracting matrices as it stands, especially some of the more complicated stuff. If you have questions, I know I didn't go over like the first page and things where we were just learning how to add and subtract matrices. If you do have questions on that page, shoot me an email and I will certainly help answer them for you. But as of now, let's hop over to 12.2 and we'll learn about multiplying matrices.